we're going to talk about related rates. So this is kind of where calculus starts to kind of show you the application. So we got two examples up here. So the first one is we have water going in a conical shaped tank. So it's coming in at a rate of 9 feet cubed per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep? Okay, so one of the biggest things in calculus and a lot of times in mathematics is when you get these story problems, try and draw a diagram. So I drew myself a diagram here, kind of showing me exactly what's happening. Here's my conical tank. I have a 5 foot radius, a height of 10, and we have water coming up here, all the way up here. We want to know what happens. So how fast is the water level rising when the water is 6 feet deep? So we want to know how fast is it going up when this distance here is 6 feet. Okay? So we kind of got to understand some pieces here. So volume is going to be in feet cubed. X is the radius of that circle and that area of the radius of that spot on my conical tank. Y is the depth at feet at time t. Okay, so we know y is going to be 6. Okay, and we also know that the volume is changing over time. So dV dt is going to be 9 feet cubed per minute. Okay, so this is my rate of change of my volume. This is my y. Okay, so if I'm looking here, my volume, if you remember, volume of a cone is 1/3 pi r squared h. Okay, well, we don't have r squared, we don't have h, but we actually do because we said that was x and that was y. So we're going to use 1/3 pi squared pi x squared y. And then what we want to know is we want to get this into terms of y. And the reason is because remember, we know we want to be at 6 feet. So we need to know how much that is changing. So if you look here and look at this two-dimensionally, these are similar triangles here. So I have a right angle here. So I'm going to set up proportions here. So x over y equals 5 over 10. So my radius, here's my radius of my smaller piece. Here's my radius of my larger. There's my height. There's my height. Okay, they're proportional. So when I do this, I'm going to solve for x. So I get x equals y over 2. Okay, so that's important because what I'm going to do is I'm now going to take this and plug it in for my x. So I end up with volume equals 1/3 pi times the quantity y over 2, quantity squared, times y. So when I square this out and I simplify it, I get 1/12 pi y cubed. Okay, so that's a good thing to know. Okay, so the reason I needed to get this in terms of y is because I'm talking about how high it's going to go, my depth. Now I'm going to take my derivative here. Okay, so my derivative dv dt is going to equal 3 over 12 pi y squared dy dt, right? Because we're taking it with regards to time. Okay, doing a little simplifying here. Okay, so let me put my dy dt here. Now we have some information, right? We know dv dt, it's 9. We know y, it's got to be 6. So we're going to plug in 9 for my dv dt and 6 for my y. We're going to solve this out. So this becomes 36. A fourth of 36 is 9 pi. We're going to divide by it. So the rate at how fast is the water level rising when the water is 6 feet is 1 over pi. Okay, so that's my rate. Feet per minute. Okay, and so that's my rate of change there. Okay, you could put that in decimal form and that's fine. So that's kind of an example of how we're using derivatives here. And we're relating rates here. So we have the rate of how fast my volume is being poured in, and how fast my height is changing, okay? So we're gonna go over one more example and kind of hopefully that will help you here. So here we have a rope running through pulley at P, okay? And bearing weight W at one end. The other end is held 5 feet above the ground in the hand of M of a worker, okay? The pulley is 25 feet above ground and the rope is 45 feet long. The worker moves away at a rate of 4 feet per second. How fast is the weight being raised when M is 21 feet from this vertical line here? Okay? So the first thing is it did give us some information. It gave us how long the rope was. Okay? So what we're going to do is we're going to look at this rope, because this rope has to go from here up to the pulley down to W. Well, I know this height is 20. So the length of this rope has to be 20 minus h, because h is this part, plus z. So 20 minus h plus z equals 45, okay? Or z equals 25 plus h, okay? That's important. Then we also know that this here forms a right triangle. So we also have Pythagorean theorem here, right? 20 squared plus x squared has to equal z squared. Okay, well, if I plug in what z was equal here, I get the quantity 20 squared plus x squared equals the quantity 25 plus h quantity squared. Okay, so now I have this in terms of x and I have it in terms of h, and it asks me how fast is the weight being raised. Okay, so we're looking at height, the change of height. So we're looking for dH dt, okay? We know dx dt, right? Because that's how fast this is changing this way. That's 4 feet per second. So what we're going to do is we're going to take the derivative of this here. We're going to take the derivative of both sides with regards to t. This is implicit differentiation. So the nice thing is I don't even have to multiply this out because 20 squared is a constant. The derivative of a constant is 0, so I take the derivative of x squared, that gives me 2x dx dt, okay? Now I come here, this is the power rule and the chain rule, so I bring the 2 down, minus 1 for my power, 25 plus h, the derivative of h is 1, and dh dt, okay? Now I'm solving this for dh dt, so all I did here was divide by 2, times 25 plus h. The 2's are going to cancel out, leaving me with x equals x over 25 plus h dx dt. Now, we have x. We know it's 21. We have dx dt. It's 4, but we need h. We need to know how high this is when this becomes 21. So we need to kind of do a little bit of solving, okay? So we're going to go back now to this equation right here, and I know x, right? X is 21. So I'm going to take that x and plug it in. So now I have 20 squared plus 21 squared equals the quantity 25 plus h quantity squared. So I have parentheses 25 plus h quantity squared equals 841. I'm going to square root that. 25 plus h equals 29, or h equals 4. Now I can take that 4 and plug it in to this equation. So I end up with x is 21 over 25 plus h, which is 4. So 21 over 25 plus 4 times 4, which gives me 2.9 feet per second. So this weight, when he's walking 4.1 or 4 feet per second this way, it's raising at a rate of 2.9 feet per second. So this is related rates. It's relating this person's rate going this way with a vertical rate of the height, okay? So we're using derivatives here and applying it to related rates.